What is fire? In many ways, we're very familiar with fire. But being familiar with fire doesn't really mean that we know what fire is. Taking place within this candle flame is a complex chemical chain reaction called oxidation. Molecules of paraffin vapor from the candle are combining with oxygen molecules in the air. As a result, energy in the form of heat and light is being produced. Water vapor, a variety of different gases, and smoke are also produced. These are carried into the atmosphere in a rising column of hot gases. The process is continuous. Heat from the flame melts more of the wax below. The paraffin is drawn up the wick, vaporizes, mixes with fresh oxygen, and is ignited by the heat of the flame. If not interrupted, the fire continues until the candle is consumed. But not all fires behave like a candle flame. To understand why, you have to know more about the relationship of fuel, heat, and oxygen. Without fuel, heat, oxygen, and the chemical chain reaction itself, fire cannot exist. Fuel is the first part of the fire equation. Many substances can be made to burn. Some are elements like carbon, hydrogen, potassium, and sodium. Some are compounds. By far, the most common fuels are compounds that contain a high percentage of both hydrogen and carbon, such as wood and paper, coal, fabrics, all the petroleum derivatives, and fuels such as propane and methane. Some are solids, some are liquids, and some are gases. The differences are important because solids and liquids do not normally burn in their original state. Only fuels in their vapor state burn. Therefore, substances which are already vapors will ignite more readily. Methane, for instance, is a vapor at normal pressures and temperatures, although it is stored and transported in pressurized containers as a liquid. When methane is released from the tank, it vaporizes immediately. Being lighter than air, it rises and disperses if not contained. A spark is sufficient to cause ignition. Many fuels exist in a liquid state at normal atmospheric pressures and temperatures, but not all liquid fuels evaporate fast enough under normal conditions to support combustion. This is gasoline, alcohol, and kerosene. The lowest temperature at which a fuel releases enough vapors for sustained combustion to occur is called its fire point. Gasoline, for instance, has a fire point well below normal atmospheric temperatures. This means that the liquid surface is constantly vaporizing at a rate sufficient to support combustion. The flames seen above the liquid surface are an indication that it is not the liquid itself that is burning, only the vapors given off by the liquid. Unlike methane, however, these vapors are heavier than air. The paper towel has been soaked with gasoline. The vapors, being heavier than air, flow downhill like a liquid.